Okay, so for this video, I'm going to be finding two ways in which we know that C3H point group must have at least two-dimensional irreducible representation, or at least have one two-dimensional irreducible representation. So as you can see, I already written some stuff down here. For my molecule, I've decided to go with boric acid. As you can see, this is in the C3H point group. Not sure if it's clear enough. And right off the bat, we can see that this has 6 different types of symmetry operations, so its order is 6. We also see that it has 6 different, 6 of those operations are different, and that its class is 6. So right off the bat, without looking at a character table, if we get our facts down, 1 second. Sorry about this. So we know that one thing we know for sure is that the number of classes of operations is going to be equal to the number of irreducible representations. What is our class here? Our class is 6. We have 6 classes. So we know that we can have 6 different types of irreducible representations as a result of that. Another thing that's important is that the sum of the squares of the dimensions must be equal to the order. Here we see that the order is 6. So that means, what does that mean altogether? Well, that means we have to have 6 different variables that equals to 6. Sorry, the other way around. We can write that down like 6 is equal to 3, 4. And right off the bat, if we were going to answer this, the easiest way to answer this would be to just put every single variable down as 1. Because square all these up, it equals 6. But we also know that we have to have at least one irreducible representation that comes down as down as 2 dimensions. So if we say have 2 down here, we're already at 4. So to get to 6, we can only really have 2 other kinds of 1s. 2 squared is 4, 1 squared, 1, 1, 4 plus 1 plus 1 equal to 6. Well, what does that mean for the other irreducible representations? They would be 0. They are the ones that would not be expressed in, they're the irreducible representations that would not be expressed. That's my explanation. If I'm being frank, I was a bit confused with the question because I know that one of these irreducible representations would have to have 2 dimensions, but I feel as though the one I have on top would be the more straightforward way of answering it. Like if every single one of these dimensions had every single one of these irreducible representations had 1 dimension to it, it equals 6. But if you put a second dimension on it, then like 3 other of these irreducible representations wouldn't be expressed. So this is just, when you see this, Dr. Moonfield, this is kind of something I just really want to ask you about. But I think to the best of my ability, I explained it well. Okay, thank you.